Hello everyone, welcome back to JDCodebase. Today is day 16 of our LeetCode study plan, and today we are solving another very important sliding window problem from the LeetCode, that is the maximum consecutive ones part 3, and its LeetCode number is 1004. Let's read the problem statement first. Given a binary array nums and an integer k, return the maximum number of consecutive 1 in the array if you can flip at most k is 0. K is 0. Like in this problem we are given a binary array, like this nums array we are given, and it has only 1 and 0. Means only these two numbers are here, 0 and 1. And in the input we are given a k a value, that is like a value k. Means we can flip at most k zeros into ones. Like here 2 k is equal to 2. We can flip 0 to 1 only 2 times in this array. Here k is equal to 3. We can flip 3 zeros in this array from 0 to 1. And we need to find the longest consecutive sub array containing only ones. This problem is very important because it teaches the sliding window technique very deeply. So let's understand everything step by step. Why I use sliding window in the past, in the last 2 videos, I already said you, whenever you see word like sub array, substring, maximum sub array, like these type of word, you must have to think about the sliding window. Anytime you see subarray, substring, or anything, any of these type of things, you must be think about this sliding window. So let's see the problem example. Like here I have the nums 1 1 1 0 0 0 1 1 1 1 0 and k is equal to 2. Here output is 6. Why 6 here? Because we can flip 2 zeros into ones, because k is equal to 2 here. And after that means we can make like these as the longest consecutive ones, like 2 zeros convert into 1 and the 4 ones are already present, so which gives us the 6 consecutive ones here. And as a result we have to give the maximum number of consecutive ones, that is the 6 here. Now main idea in this problem is like we create a window. As the sliding window we are using, so we create a window. Inside that window we allow at most k zeros, and if zeros become more than k, we shrink the window from the starting of that sub array, and this is called the sliding window. Means in the sliding window everyone knows we remove the element from the starting of that sub array and add the new numbers from the end of the array. So that is the main idea. So let me write the code so you can understand it. Let left is equal to 0 means it is the starting index. It denotes the starting index of that sub array. Let 0 count is equal to 0. So we can check out how many zeros till now we are check. Let maximum length is equal to 0, and this maximum length we have to return from this function. Start a for loop. Let right side of right is equal to 0, and right is always smaller than nums dot length and right plus plus. So this right represent the last index of the subarray. Means just a normal for loop I start here, and if nums of right is equal to 0, we have to 0 make count plus plus, means we see a 0 here. And if means I see the 0 while 0 count is the greater than k value, then if nums of left value is equal to 0, then 0 count minus minus, and left plus plus every time. Why I write here means why I check the zero count greater than k or zero count minus minus. See, I check, I am just using this array. Just take this array here. I check at initial time 1 is present, then 1 1 in the sub array. Then in the sub array I get the 1 1. Then I get the 1 1 1 and 0. And it is acceptable. Why? Because 0 is 0 count is 1 here, and k is smaller than 0 1 is smaller than 2. In the next time I see 1 1 1 0 and 0. It is again acceptable here. Now in the third time, in the sixth time, when I write here 1 1 1 0 0 0. Now this time 0 is the out of the bound, means k is equal to 2, and I only can flip the two zeros from this sub array. So now I have to remove the 0 from the left side, means from this starting index. And for that we have to means make the 0 count minus minus and left plus plus. So means if nums of left is equal to 0, means I just reach at this point at this index, means 1 1 1 0 I just pass, and I reach at this point, this highlight 0. So 0 count minus minus and left plus plus every time, means I just reach here. And after that calculate the maximum length is equal to math dot max maximum length, and it's right minus left plus 1. Why I write here maximum length right minus left plus 1? Why? See, right is 0, left is 0, maximum length is the 0 here. Oh sorry, 1. And after that here at this point, sorry, maximum length is 1. Why? Because this 0 minus 0 plus 1, so it's 1. Here 1 minus 0 plus 1, I get the 2. 2 is the maximum length, as means I am just see, you can see visually here, means the maximum length is 2. Then 2 minus 0 plus 1, I get the 3 as the maximum length. Here also 3 minus 0 plus 1, 4 as the maximum length, and here also 4 minus 0 plus 1 is the 5 as the maximum length till now. Now here I get the while 0 count is greater than k. 0 is greater than k, yes it is greater than k. So now we have to check out this condition, means look out at this condition until the 0 count minus minus, means until it comes to the normal range. So for that I have to like 5 minus here left plus plus every time, means I just move the left now 1 2 3 4 4 time I remove the left. 4 minus 5 minus 4 plus 1, that is the 2. Now next time I get in the maximum sub arrays like 0 0 and 1, means I just start the next one like 0 0 1, this one. So now right is like 6 minus 4 plus 1, that is the 3. And in the next time 0 0 1 1. Now this is the 7, right is at 7th index, 4 left is at 4th index, and plus 1, and I get the answer 7 minus 4 3, 3 plus 1 4. And here again 0 comma 0 comma 1 1 and 1. Now I get the 8 minus 4 plus 1, that is the 5. Again new array 0 0 1 1 1 1. Now this time 9 minus 4 plus 1, I get 9 minus 4 is 5, 5 plus 1 is 6. So I am reached at this position, means this is covered. Now again this time this 0 come here. So this time again 0 come. So let's see 0, comma 0, 1, 1, 1, 1 and 0. Now this time 0 count is again exceed the limit, means its 3 is greater than 2, that is the true. So for that 0 count minus minus, remove this 0 from this and left plus plus. Now this time at is 10th index, 5 is the left value because left plus plus done this at this point, and plus 1. 10 minus 5 plus 1 is the 6, and in last we get the maximum length as the 6 and return this maximum length. So let me comment this so I can run this, else I get the error of this. Yes, it accepted. Let's try to submit the solution. Yes, it passed all the 60 test cases and our solution is accepted. So basically the window should always contain at most k0. See in this example, like in the visual, if you see only no 0, 0, no 0, 1 0 here, 2 0 here. Maximum limit is the 2. Whenever I see the extra 0, I have to remove that 0 from the left side. Means remove the left side value from left side of that sub array entirely. Then I get the new array is the 0 0 1, then 0 0 0, then 2 0 again, 2 0 again. This time again 3 0 comes. So we again have to remove the left side array until I reach the 0th. So I can means get the exact 2 zeros here. So if zeros become larger than k, shrink the window. This is the main motto of this my method. And otherwise expand the windows entirely. Like I'm just expanding like 2, 3, 4, 5, 6. So this is the heart of the sliding window. Expand the windows or shrink the windows. And time complexity for this problem is like big of n, because there is only one single for loop is running, and because every element enter the window 1 and leave the window once, and space complexity is the big of 1 because no extra use of any array or set or any other thing. And that is for this video, and that's how we solve the maximum consecutive ones part 3 using the sliding window. And this is the most important interview pattern, so make sure you practice this properly. And if this video help you understand the problem, like the video, subscribe to JDCodebase and comment day 16 done, and I will see you in the next video.